Okay.
Yeah. Good afternoon, one and all. My name is Ravi Kiran Uppala. I'm working as an assistant professor in Mallareddy Engineering College for Women, Mysamagoda, Secunderabad. Today I'm going to talk about fiber optics. Now in this topic, so we are going to discuss about what are the optical fibers and what are the importance of optical fibers and the working principle of optical fibers and some basic important terminology like numerical aperture, acceptance angle, and these kind of things we are going to discuss. And in additional to that, we are going to see different type of optical fibers and losses in optical fibers. Finally, we are going to discuss about some few important application of this fiber optics. So mainly here, the fiber optics is a branch of physics which is deals with the transmission and the reception of a optical energy as a waveguide. So before invention of this optical fibers, so we have used copper wires or conductors as a waveguides. But so we have a many more challenges while we are using the conductors as a waveguides. So we can the if you see the output of any conductor, like mostly, so we have gone with the copper wise, we can say up to more or less 50 to 60% of the output only we are used to get over here. And moreover, it is very much limited, so we are unable to send so multiple signals simultaneously using conventional copper wires. So once we have done with this optical fibers, so so these are very fast way of communication. So waveguide, so these are the optical fibers are the best. And moreover, so whatever the energy we are sending at the as an input, the same almost the 99% of energy we are going to get from the output of this optical fibers. Now here already we talked about what are the different topics we are going to cover. So I am mentioning over here. Yes, so these nothing but the basic definitions already we have seen. So these are literally nothing but some basic, we try to get an idea of what is the optical fiber and what is normal thing. So these nothing but this is a normal plastic pipe. So whatever the light, whatever the water which is incoming into the pipe, the same amount of water is coming out from this pipe. So whereas in the similarly, so this is nothing but a waveguide. So this waveguide we are using as an optical fiber cable we are using as a waveguide, and this is nothing but incoming light energy. So it undergoes the multiple reflections, total internal reflections, and finally, so we are going to get the more than 99% of the output. So these are some of the some pictorial the visualization of a this thing. Yeah. Now we can. These are some of the examples. Anyway, we can go through it quickly. We can see some important layers of this optical fiber cable. So mainly, so which is consist of a three important layers. So those we can call it the core, cladding, and buffer. The core is nothing but which is made up of a dielectric material such as plastic or glass, and the refractive index of core is quite higher than the rest of the layers. And if you see the diameter of a core, which is around 8 micrometers. The next one, the another dielectric layer which is covered around this core, so which is also made up of some plastic or glass material. So if you see the diameter of a cladding is quite significant than that of the core, so which is in order of 125 micrometers. So these two, core and cladding, so will be surrounded by the another protective layer. Usually we can call it as a buffer or a jacket. So these fourth and fifth layers are nothing but a protective layer, so which can protect the optical fiber cable from twists and turns. So the diameter of this buffer and jacket is quite higher than that of the core and cladding. If you see, so these are the major components or major layers of this optical fiber cable. Now we can see the refractive index of core is quite higher than that of the cladding. So then that means the core it can act like a denser medium, and here the cladding it can act like a rarer medium. So we can go further. So these are the discussions already we made here. So this is nothing but a simple diagram here. So we are taking the air medium as a first medium, and this is nothing but a blue color one is nothing but another medium. So whenever the light incident on the interface of two medium, the three phenomena will happen. So one is nothing but some amount of energy will be reflected back into the same medium. We can now call it as a reflected ray. Some amount of energy, the partial, very little amount of energy will be absorbed by the material or medium, and the remaining amount of energy will be refracting through the material. So whether it is a refracted ray, it is moving nearer, it is moving toward the normal to the medium, or it is moving away from, that depends upon the ray, so which is traveling from, whether it is traveling from rarer medium to denser medium or denser medium to rarer medium. Okay, now in this case the light is traveling from here rarer medium to denser medium, and if you see the angle between the incident ray and the normal to the interface of two medium, we can call it the angle of incidence, and the angle between the normal to the refracted ray, this we can call the angle of refraction, and as well, so this is nothing but a angle of refraction. So in this optical fiber, so we are more or less we are going to handle with the angle of incidence and angle of refraction. Yeah, so this is one of the example over here, already we talked about it here. If now this is nothing but in the case 1, so we can take the this is a first medium, this is a denser medium, and this is a rarer medium. So whenever the light traveling through denser medium to rarer medium, then the refracted ray which is moving away from the normal to the these two mediums. So whereas here, if the same light ray which is traveling from rarer medium to denser medium, so it is approaching towards, or it is moving towards the normal to this medium. So this is because of whenever the light is moving from one medium to another medium, the speed of light that varies. So it depends upon the variation of speed of light. So that can travels with a certain angle than that of the actual angle. Okay, with the same these two diagrams, we can try to write down the Snell's law. The Snell's law we may define as here the sine of and the ratio of sine of angle of incidence to angle of refraction. So that is equal to the ratio of the refractive index of a medium number 1 and a medium number 2. So these are all about how the ray is refracting, so which is moving towards the normal to the line, or which is away from that depends upon the where it is traveling from, is important thing here. So we are going to see the important how the light is getting how the light suffers total internal reflection in optical fiber cable, that means indirectly. So we are going to discuss about the working principle of a optical fiber cable. Here we are taking two mediums. So the medium number 1 as a N1, the refractive index of medium number 1 we are taking as a N1, and the refractive index of second medium is nothing but N2. The refractive index of air N2, it is always lesser than that of the refractive index of N1. Okay, so whenever the ray is propagating from denser medium to rarer medium, it gets refracted through the medium number 2 at a particular angle of incidence. Now, so as we are keep on changing the angle of incidence, at a particular angle of incidence, the refracted ray which is passes along the interface of two mediums, that means, so here the angle of refraction R is equal to 90 at a particular angle of incidence, so that we can now call it as a critical angle. So this is happens at a particular angle of incidence only. If the angle of incidence is more than critical angle, then the light will be reflecting back, or it is coming back into the same medium. That means the total light is coming back into the same medium. Indirectly we are discussing about the total internal reflection. That means whenever the light is passes through denser medium to rarer medium, and whenever the angle of incidence is greater than the critical angle, then the light suffers total internal reflection, or it undergoes the total internal reflection. So based upon this, so we can construct the optical fiber cable, and we can explain about the propagation of a light wave. So this is nothing but an example of a propagation of light wave. In this way, so we can use this optical fiber cable as a waveguide. Thank you.